With some trig identities, and we're going to use these in order to we're going to be given basically a function. We have to change it, simplify it, and we're going to use trig identities to do that. We're also going to use trig identities to prove and verify trig equations that are given to you. So an identity is just something that the left side is equal to the right side for any variable we put into it. So an identity could be, you know, x equals x. That's actually an identity because both sides, no matter what x is, will be equal on both sides. We already talked about most of these. All right? We're just going to go in more detail about it. So maybe we looked more about this right side where we said that if I have cosecant, I could just rewrite that as 1 over sine. If I had secant, I could just rewrite that as 1 over cosine. If I had cotangent, that was just 1 over tangent, right? They were just reciprocals. Oh, it works both directions. If cosecant equals 1 over sine, that also means that sine equals 1 over cosecant. Just like cosine x equals 1 over secant, and cosecant equals 1 over sine of x. Basically, they're just all reciprocals of each other. You will need to know all of this information, okay? It's not all that much. Most of it is just adapting what we already know to kind of a new situation. Like we knew all of these. We may not have focused too much on this, but we know all of this. We also know that tangent equals sine over cosine. We worked on that, which means that cotangent is its reciprocal, so that's cosine over sine. We also already talked about the Pythagorean identity, particularly this one. This guy right here, and we'll talk about the rest of them in a second. But we already started talking about this one in the last unit. We used sine squared plus cosine squared equaled 1. Remember when I give you like an angle? I would say the cosine is 35 degrees. We're in quadrant 4, so you need to plug it back in to find your sine. Well, we already used that, and we'll talk about how we get all these, but everything else is based upon this one fact. So if you know this fact, you actually know all of this information. The ones we haven't talked with, we're going to talk more about it tomorrow. You're going to need it a little bit in your homework, so that's why I threw it in here, is the odd, even identities. In short, if you take sine of a negative number, so say I take sine of negative 2, that's the exact same answer as if I do negative sine of positive 2. All right, so that negative sign can go either place, and it's the exact same answer. So sine of negative 2 is the exact same thing as negative sine of 2. That works for cosecant. The same applies to tangent, all right, and cotangent. If I have a negative number on the inside, I can pull that negative out front, and it'll be the exact same answer. The one that's a little different is our cosine. Oddly enough, cosine of a negative number is the exact same answer as cosine of that positive number. So cosine of negative 2 is the exact same thing as doing cosine of 2. And that applies to secant. The secant of a negative number equals just the regular secant of that number. So if I had a highlighter or something, I'd probably highlight this one because that's the weird one. That's the weird one you need to know, that negatives don't apply when they're in the inside. You come up with the exact same answer if it's positive or a negative. All right, I want to talk about those Pythagorean identities first of all, because just in case we don't remember when we get to a test and I'm not sure which identities they were. Well, we should know this one. This is just basically a squared plus b squared equals c squared. Remember with our unit circle because our hypotenuse was 1? Well, if we know that, if I know from the unit circle that sine squared plus cosine squared equals 1, I can manipulate it by just, in that first example, is dividing everything by sine squared. So I'm going to divide both sides by sine squared. And this is just to change the look of it. So you have sine squared alpha, divide everything by sine squared alpha, divide 1 by sine squared alpha. All right, now I'm allowed to divide both sides as long as I do the same thing to both sides. And I did. I divided by sine squared alpha on both sides. So I'm going to look at sine squared alpha divided by sine squared alpha. Well, anything divided by itself is just 1. So that's just going to be 1. plus, well, I have cosine squared over sine squared. So if I look back up here and I look for cosine over sine is equal to cotangent. So rather than saying cosine squared over sine squared, I'm going to say cotangent squared alpha. Because this is squared and this is squared, then this will be squared as well. All right, and that's going to equal 1 over sine squared. Yeah.
No, wait, never mind.
You sure?
Not adding up. Yeah, I figured it out.
Okay. And all I'm going to do is I'm going to say, well, I don't want to write 1 over sine squared because we can look back up here and say, well, 1 over sine just equals cosecant. So this is just going to equal cosecant squared alpha. All right, that's where that other trig thing came from, this one right here. Because I just divided what we already knew by sine. That gets me that one. Our other one's going to be created by dividing everything by cosine. So if I do the exact same steps, except I'm going to divide everything by cosine squared alpha, divide this by cosine squared alpha, and finally divide 1 by cosine squared alpha. Well, sine divided by cosine, that's just tangent. So rather than writing sine squared alpha over cosine squared alpha, I'm just going to write tangent squared alpha. Well, cosine squared alpha over cosine squared alpha, that's the same thing over itself, so that's just going to be plus 1. And that's going to equal 1 over cosine squared alpha. I don't want to write 1 over cosine squared alpha. So what could I write in its place? Yeah.
Secant squared alpha?
Yep, we're going to write secant squared alpha. Those are the 3 big guys. Those are the 3 big guys. All right, and I'll come back to the slide if you're not done writing. But these are basically our 3 big guys. Here's a couple variants. There's also more. There's more variations of it than this. Because you could have sine squared minus 1 equals negative cosine squared x. All right, so you can always manipulate these however you want to. And what's going to trip you and say, hey, I need to look at this Pythagorean theorem, is if you see numbers that are squareds and you see 1s in a problem, it's usually going to have something to do with our Pythagorean identities. All right? So get that locked in your head that if you see stuff that's squared and you see 1s, like minus 1, plus 1 or something, you're usually going to go back to one of these identities somehow, some way. All right, but those are the 3 big guys. All right, but if you know sine squared plus cosine squared equals 1, you actually know all of them. It's just whether you divide by sine or whether you divide by cosine gets you the other 2. All right, any questions on those? Okay. Then what exactly are we doing in this unit? Well, to start off with, we're going to use these trig identities to simplify problems. Because right now we have tan x over secant x. And you might say it looks small enough, but we can simplify that even further. So the directions say we're supposed to write each expression in terms of sines and cosines, and then we're supposed to simplify it. So let's go ahead and start. How can I write tangent? Tan x using sine and cosine. Yeah?
Sine x over cosine.
Yep. So we're just going to write sine x over cosine x. So that's the top of it. And can someone else tell me how I can rewrite secant in terms of either sine or cosine? Yeah.
You do 1 over cosine x.
I can do 1 over cosine x. All right. Now, for those of us that may have forgotten, I have a fraction divided by a fraction. All right. So we are going to use keep, change, flip. All right. Where I keep the first thing, I change my sign to multiplication, and I take the reciprocal over here. I think I still have an example up there that was helping us. So if you want to see it with just regular numbers, that's what it looks like. But in short, we keep the top fraction over cosine. We change our division sign to a multiplication sign, and we take the reciprocal of cosine of x over 1. In other words, you kind of flip this and throw it up here. Well, cosine x over cosine x, that's going to cancel out. And sine x over 1 is just going to equal sine of x. And in my book, sine of x is a lot easier to plug into my calculator than this a bunch of times. So that's what I mean. We're going to simplify. And if you're doing these problems and it keeps getting bigger and bigger and bigger and more complex, you probably made a mistake somewhere along the line. All right? It might turn out complex at first because this looks more complex. But we notice from here it should whittle down to a smaller problem. All right? So if this started getting bigger and bigger and bigger, then I'm going to think might have made a mistake. Okay. Our next one. Well, this one is, I already have a sine. I already have a cosine. So the only problem I have right now is that cotangent. I got that cotangent guy right there that I need to rewrite. So I don't need to rewrite the sine, so I'll just put sine of x plus, how can I write cotangent in terms of sine and cosine? Yeah, Nisha. Cosine over sine. So we'll do cosine of x over sine of x, and we're multiplying that by cosine of x. Well, I'm just going to rewrite that as sine of x plus cosine squared x all over sine of x. Because realistically, this is cosine over 1. We just multiply on the top. I am not done. I am not done. Usually when we simplify, we're going to be able to go much further than this. Okay? So the key here right now is I need to combine fractions. And what do I need to combine fractions? I need a common denominator. So right now, sine of x is my denominator here. So just like I would with anything else, I'm going to multiply this by sine of x over sine of x, and we'll see what happens. So maybe I'll put a little note on the side that I'm multiplying this by sine of x over sine of x. Okay, and that's just going to equal, well, sine of x's across will be sine squared x over sine of x plus cosine squared x over sine of x. Now let's make sure that everything's okay, that I did everything correct. With sine squared, so that's sine times sine divided by sine, does that still just equal, that's a lot of sines in one thing. Does that still equal sine though? Yeah, it's like x squared divided by x. That still equals x, right? I just changed the look of it. Did you have a question? Sorry.
So, like, actually, never mind. I got it.
You sure?
Yeah.
Quit answering your own questions, people. That's what I'm for. Okay, so now we're going to combine them because they have the same denominator. So if they have the same denominator, we're going to do it just like everything else. We'll have sine squared x plus cosine squared x all over sine of x. Not done though. Not done though. This is a lot quicker on your own rather than me stopping. Look at that top. It says sine squared x plus cosine squared x. What could we write that as? If you're not sure, look at your identities. It's going to be one you're going to be using a lot. What does sine squared plus cosine equal? Yeah. It equals 1. So sine using we go back. So if we go to our Pythagorean identities, remember I said look out for squares. If you see squares, you're most likely going to do something with this. We're going to go to that sine squared plus cosine squared equals 1. So that just equals 1 over sine of x. But what does 1 over sine of x equal? John? Cosecant. So the other class had a great question. They're like, cosecant isn't sine or cosine, right? But if you look at the directions, it says, write each expression in terms of sines and cosines. All right, that just tells you your first step. It tells you to write in sines and cosines, and then simplify. So your final answer might not have any sines or cosines in it. So it just says your first step is convert everything to sine and cosine, and then just go with it until you get to the end. Whatever your answer is, that's what we got. So we converted everything to sine and cosine, so our answer doesn't have to be sine or cosine, okay? It's important that you recognize that. That you're not like, well, I got to stop here because that's not sine or cosine. It's okay. Yeah, Willie.
So, why does the sine 2x and cosine x, why do those cancel out? Like, how do those add up to 1 again?
How do these add up to 1?
Yeah.
It's just the identity. It was, we did that with the unit circle, where we said a squared plus b squared equals c squared. Well, our hypotenuse was 1, so it's basically x squared plus y squared. So it's just substitution. It really is just substitution. That I can either write this, or I can write 1. 1's a lot easier to write. All right, final one. Oh, yeah, sorry.
Are you gonna have to have us memorize this like we memorized the unit structure, or will you just give us?
You're going to need to know that. You should know most of it already.
Okay.
You should really know most of it already. You should know your cosecants, secants, cotangents, and all that. And you should know sine squared plus cosine squared. It should be a lot easier to memorize this than the unit circle. It should be. All right, and you're going to be using it so much during practice, you'll just know this stuff.
Okay.
You'll see sine squared, cosine squared, you'll be like, awesome, I know that's fine. All right, so it won't be as bad. All right, so here I have tangent, cosecant, I got secant, so I need to change all of them. So the first one I'm going to change is my tangent. Can someone tell me how to rewrite tangent?
1 over. No.
Sine of x over cosine of x.
Sine of x over cosine of x. Here's a little hint to save you a little bit of time. These all have x's in them, right? There's no other variable in here. So what I do to save some time is I'm just going to put sine over cosine, and it's going to be implied that there's x's attached to it. It's just rather than having to write x a whole bunch of time, it's just sine over cosine. All right, we're going to multiply that by cosecant. Well, cosecant deals with sine, so that must be 1 over sine. And secant is 1 over cosine. Well, let's simplify that top first. So our sine over sine, that's going to cancel out. And we're going to have 1 over cosine all over, we have to put an equal sign, all over 1 over cosine. Now you could go through all the trouble of doing keep, change, flip, but it's much easier to recognize that I have the same thing on top as the bottom. Something divided by itself just equals the big uno. And I think 1's a lot easier to use than to plug this into your calculator a whole bunch of times. In my mind, I mean, maybe you like doing this in your calculator. I'd prefer just putting 1 down. Okay, so that's the whole thing of what we're doing today, is we're taking items like this and we're simplifying them, putting it in a much easier form to be able to write, to be able to solve stuff with, so that later on when we get to later sections of this unit, it'll be a lot easier. All right? So your homework is just simplifying some stuff. I want to talk about one part of your homework, and that is the very last couple questions. Well, not couple, because that'd be 2. The last section of questions. Just because for some reason it looks a little confusing. But it says match each given expression with the equivalent expression a through p from the bottom. So all you need to do is look at sine of x. And you're going to go through all of these, and you're going to find the one that equals sine of x. So if you're going all the way through, well, it can't be that because there's no negatives. No, 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 no. You'd get to h. And h is the 1 over cosecant of x. And cosecant is the reciprocal of sine. So you're just going, all you have to do is put an h next to it. Be aware, did I cross out h? I did not cross out h because these can be used more than once. Not saying they will be, but they can be. Oh, life is so hard. I just like when I can cross something out and be done with it. Oh yeah.